Is my audio clear?
Yes.
Okay, so let us start the seminar. So myself, Gokul, I am coming from Mangat, and I have completed my degree in BSc Computer Science from Talkramba Arts and Science College. So today's seminar is about SD-WAN, that is software defined WAN. So now I am going to present my screen. So my slides are uh, clear. Is it? Is it?
Yes, yes.
Okay. Then today's seminar's topic is SD-WAN, that is software defined WAN. So we have studied about networking in our MCA syllabus. So the basic idea of any network is the OSI model. Uh, that is a reference model for any network. So SD-WAN is a type of WAN networking where we imply the software for uh, for cleaner networking through the WAN network. So, so the next slide, I have shown the topics that we are going to discuss today. They are networking, WAN networking, SD-WAN, structure of an SD-WAN, concept of SD-WAN, benefits of SD-WAN, then the disadvantages that are faced by an SD-WAN network. So at first, we are going to look on to the small definition on network. So many of you will be familiar with the definition for a network. So I just run through the definition for network. So we can define a network in a in computing as a group of devices or nodes that can communicate with each other. They are connected physically or wireless. So the nodes or devices can both physically or wirelessly connected with each other for information interchange. The scale of network can range from a single pair of devices or nodes sending data back and forth to massive data centers and even to even the global internet. So internet can be defined as a large network. So let us move on to the next slide. So in the next slide, I have displayed the type of networks. Some types of network are seen here. These are the common networks that we usually see. They are LAN, WAN. LAN stands for wide area net. LAN stands for local area networks, whereas WAN stands for wide area network. Then LAN, that is a local area network, constitute a small geographical area, uh, and the communication within the small geographical area. We can say, for example, the school campus can be defined as a local area network, whereas wide area network cover a large geographical area. So we can say as a wide area network as a collection of WANs, as a collection of LANs. The LANs are connected with each other by a routing device which connect the LANs with each other for creating a wide area network. So next comes the wireless local area networks. The wireless local area networks is a type of local area network in which a person can move around a larger area without a physical connection and still can pass information within the network. Next is MAN, that is Metropolitan Area Network. MAN cover a small city or a town. So the network within the city or a town can be defined as a metropolitan area network. Next comes the storage area network, SAN. SAN is used for connecting a device or a cloud device with a remote branch having the storage area. By using a stand, we can easily ac- get access to a storage area that is constituted in a remote branch location. Next comes the canvas area network. The canvas area networks, we can say, for example, in a university campus or any business campus where a local network is provided. This network can be defined as a canvas area network. Then it comes the personal area network. The personal area networks we can define as if we can as if we want to connect to printers or scanners in with our computer device. We use a personal area networks for personal users. So I think this slide is the types of networks are clear to you. Next, we move on to the next slide. Next is the WAN. The WAN may be more similar to you, similar for us as we study WAN in our networking syllabus. So let me move on to the description for WAN. The WAN can, spans a large physical distance. The internet can be defined as the largest WAN spanning the earth. So as we said, the WAN is a geographically dispersed collection of LANs. As I said in the previous slides, LANs are interconnected with each other to create a WAN, that is wide area network. The device which is capable of connecting these LANs are said, can be said as routing devices. These routing devices connect the LANs to create a WAN. So there are many different ways by which a WAN differ from a LAN. So uh, they are, we can say, as WANs aren't owned by a single organization. Instead, WANs exist under the collection or a distributed ownership and management. So we can say the lands are locally owned, and WANs in that case are owned by a group of organizations. Uh, at the last point, I have included technologies which are used to implement a wide area network. They are ATM, frame relays, etc. So the next slide, as we have discussed, we are going through SD-WAN in this seminar. Now I have pointed out the disadvantages that are faced by a WAN network, because of which the SD-WAN is more flexible compared to a WAN network. So the disadvantages faced by a WAN network are security problems. So the security problems are the major disadvantage that are faced by a WAN network. So WAN has more security problems as compared to MAN or LAN. As we can say, the LAN or MANs are covering a smaller area so the WAN are created by connecting these LANs with each other. So there is more technologies combined with each other. So there is a case when there may be a security gap created within these LANs. So that is for the security problems faced by a WAN. Next is the next disadvantage that is faced by a WAN is the need for firewall and antivirus softwares. So as data is transferred on the internet can be accessed and changed by hacker. So the firewall systems are needed to be enabled in the computers. So people can also inject virus into the computer. So antivirus software are needed to be installed in each of the systems that is present in a WAN network for more secure information interchange within the WAN network. Next comes the cost. So the cost is a major part or a major disadvantage that is faced by a WAN network. So there is a high cost for setting a WAN network. So setting up WAN for the first time in an office costs higher money. So it may also the setting up of a WAN in a office for the first time include purchasing of routing devices, switches, and extra security software that are needed to create a WAN. So, the next disadvantage that is faced by a WAN is the troubleshooting problems. So, as the WAN covers a lot of area, so fixing problems is very difficult. Most of the WAN wires go into seas and wires get broken sometimes. So it involves a lot of resources to fix the lines under the seas. We may be knowing about the internet service providers. The head office may of these ISPs may contain many internet lines. Routers are mixed up in rooms, and fixing issues on the internet require a full-time staff. So, as we said in this point, there is a need for a full-time staff in case of any trouble that occurs in a WAN. So next comes the server down and connection issues that is faced by a WAN network. As many of us be familiar with server down problems, if in case of some site we may see the server down error message that comes. So, in case of any electricity power down or internet issues, there may be a case when the user cannot reach the server. So, this is a major disadvantage of a WAN network. So, I think this disadvantages of a WAN network is clear to you. So, is it clear? Can somebody respond?
Yes, clear.
Okay. Then let us move on to the main topic that is SD-WAN. So the seminar is on SD-WAN. So let us move on to the small definition on SD-WAN. So SD-WAN stands for Software Defined Wide Area Network. So SD-WAN is a virtual WAN architecture in which a blend of network transport types, not only multi-protocol label switching, but also broadband, broadband internet, cellular connections, and satellites are virtually bonded in SD-WAN network. There is a centrally located device or a central management device or software that is provided by the SD-WAN to centrally manage these internets or networks that are included within the SD-WAN by a software. So we can say the SD-WAN is a virtual tunnel that is created over various type of networks. So we can uh, manage the network flow through these networks by specifying the our needs in the software that we install uh, for SD-WAN. So we can easily communicate by using an SD-WAN. So essentially, the SD-WAN is a software-defined networking for a WAN, that is the wide area network. So next is a figure that I have shown for a SD-WAN. So as we can see, there are SD-WAN gateways present, and MPLS and Internet are the networks that are present within the SD-WAN. So the gateways are both present in the sender end and both the receiver end. So if in case of a request that is sent through the gateway in the sender end, the information can pass both through the MPLS and internet, and then this information pass through the gateway in the receiver end and concluded in the receiver end. So, as I said, the SD-WAN include both MPLS and internet in this, as I displayed in this figure. So the information can pass through both MPLS and internet. So faster communication takes place in case of an SD-WAN. So this figure is quite simple. Uh, so let us move on to the next figure. The next figure shows the current state of an enterprise WAN. So as I have labeled in the figure, the two branches and data center. So the branches supply the information or the request to the data center. So in case the branches select the MPLS network for sending the information to the data center, the routers present in the branches select the MPLS and passes the information only through the MPLS to the data center. So the information through the MPLS reaches the router in the data center and stores in the data center. So in case the branches are accessing the internet and that is present. So in case of WANs, in case we are using an internet, it will only use the internet for passing the information and then pass the information to the data center. Where in case the data center contain firewalls and apps to uh, make the information in case any hackers get access to the information, the firewalls are present to prevent it. Whereas we can see an IPsec that is present in the figure, though we can say the IPsec as a VPN technology for safer information interchange within the internet. Many of us will be familiar with VPN technology. So it is used for accessing the internet safely. So IPsec is a VPN technology to safely send the information through internet. So in the next slide, we refer to the key features. These key features would be further explained in the seminar. So the key features of an SD-WAN are transport independence. That is, as we said, SD-WAN includes many networks and create a virtual network in between them. So the SD-WAN, in case of transport independence, we can say it uses both broadband LTE and MPLS for uh, information interchange. Next is the secure overlay. Uh, so SD-WAN uses applications like firewalls and cloud VPN to secure the information that is passed to the SD-WAN. Next is the dynamic path selection. So the dynamic path selection is the major feature of an SD-WAN. So it will be further discussed in the slide. Next is the symbol interface. We can say the SD-WAN has zero touch provisioning and an orchestrator is present to centrally manage the SD-WAN. So these terms like orchestrator will be further discussed in the slides. So I just move on to the next slide. The next slide describes the network agility of an SD-WAN. So SD-WAN is cloud delivered and software based technology. So it allows for quick adaptation to changing needs, including adding access to cloud based servers, standing up new branches or remote offices, and dynamic routing of all traffics for optimized application and data delivery. So network agility can be defined as a major advantage for SD-WAN. As we have said, the SD-WAN is software based. So any changes that is done that must be done to the network can be easily implied to the network by changing the software or by inserting any changes that is needed to the network to the software which controls the network. So, for concluding this slide, we can say we can easily insert any devices or branches to the SD-WAN network without making any interference to the existing network. So next we move on to the benefits that create the SD-WAN more advanced, more uh, important than WAN. So the first benefit that SD-WAN provide for a user is SD-WAN offers automatic failover to other transport mediums. For this benefit, we can say uh, if in case there are three mediums connected in SD-WAN router such as DSL, fiber, and LTE that are networks present in SD-WAN, if in case the information is passing through DSL and DSL fails, the SD-WAN router sends the traffic, that is the information, through any of the other two mediums, that is the fiber and LTE. If in case the fiber we are sending the traffic through fiber and fiber fails, then the SD-WAN sends the information through LTE. That is the next networking medium. As I explained with an example, SD-WAN offers automatic failover to other transport mediums. So next we move on to the next benefit, that is it offers great cost benefits due to leveraging public internet over expensive MPLS. SD-WAN sends low priority, less sensitive data over cheap public internet lines such as reserves private links for critical and time sensitive data such as VoIP. VoIP stands for Voice over IP. That is used in case we are using any voice messages within the network. So as I said in this benefit, uh, as I also mentioned in the definition of SD-WAN, SD-WAN covers different kind of networks. So SD-WAN includes different kinds of networks. So SD-WAN user has a privilege to send less priority data through uh, local internet lines and reserve the private links, that is more secure networks, and send the critical data through these networks, which make the more secure information interchange through the SD-WAN network. Next benefit of an SD-WAN is that SD-WAN provides ability to incrementally add resources and interpret with existing devices and circuits. So we can easily add any resources within a existing SD-WAN without interfering any the inter without interfering with the network that is already existing. Next is the next point is the organizations already using an MPLS can easily migrate to SD-WAN solutions without changing the existing MPLS network. So, uh, okay. So the next benefit of an SD-WAN is that SD-WAN dynamically shifts traffic to links having good amount of bandwidth. This, along with WAN optimization technique, help to improve performance of applications. Moreover, it assures application performance continuity and rapid deployment and automation. So, as we said, the SD-WAN is centrally managed by a centrally managing device. So, we can easily uh, handle an SD-WAN compared to a WAN network. Next is it delivers efficient WAN utilization by unifying all available WAN links to deliver aggregate to aggregate deliver in aggregate capacity. So the SD-WAN uh, makes the existing WAN network more efficient by utilizing each of the network that is present in the existing WAN network. So then we come to the next benefit, that is it offers simple consolidate IP stack to the edge of the existing network. Moreover, it is easy to insert SD-WAN in the existing network. So this benefit is already discussed. Uh, so these are the benefits that an SD-WAN give for a user who is using an SD-WAN. Okay, so I think the benefits are clear. Next, we move on to the ease of deployment. So SD-WAN offers the ease of deployment to the user who is using an SD-WAN. So the SD-WAN allows for various deployment options. So there are various deployment options for an SD-WAN. They are completely cloud-based deployment or software-based, hardware-based or hybrid. Though the hybrid deployment option contain both cloud, software, and hardware-based deployments. In each instance, all components are able to connect to each other when brought online, and configurations are pushed from the central monitoring device and management device called orchestrator. So the term orchestrator is new to us. So orchestrator is the central management device that centrally manages the SD-WAN network. And in case if there is any problems that is occurred in SD-WAN, the orchestrator creates the message to the SD-WAN handler that there is a message problem uh, that have been occurred in the SD-WAN. So the central management of an SD-WAN network make make it easy to deploy. So there is no need for a specialized technician to facilitate the installation of an SD-WAN. So this is for the ease of deployment that is given by SD-WAN network to the user. So the next we come to the central management and control of the SD-WAN. So the term orchestrator is mentioned here. The a centrally located device that monitors the network activity, alerting of problems in the network and enabling the remote remediation of issues is known as the orchestrator. The orchestrator, as we said, monitors the network activity that is taking place in the SD-WAN. So the orchestrator enables the automatic push of configurations to each network nodes and added accessibility to common software platforms to every location quickly and efficiently. So, as we discussed in the previous slide, the ease of deployment of SD-WAN. So, the orchestrator plays an important role in ease of deployment. That is, I have mentioned here that the orchestrator automatically push the any configuration changes to each of the nodes or devices that is present within the SD-WAN network. So, in addition, it delivers real-time analytic and reporting. So, the orchestrator delivers real-time analytic and reporting of any problems that occur within the network. So next we move on to the concept of an SD-WAN. I think the benefits have been more easily explained in the previous slide. Let us move on to the concepts of an SD-WAN. So by moving on to the concept of SD-WAN, the underlay tunnels and overlay tunnels are mainly two terms that are usually used in an SD-WAN when we explain the concept of an SD-WAN. So, in case the underlay tunnels, we can say the underlay tunnels are physical transport uh, transport networks. For example, we can say the MPLS, Internet, and LTE, or other transport that are usually used. So, the underlay tunnels which by the physical networks that are present. Whereas overlay tunnels, so the overlay tunnels are a major term that is usually used when we explain an SD-WAN. So overlay tunnel stands for the logical connection that is created So as we mentioned, the SD-WAN uses the logical connection that is created over the uh, existing network. So the overlay tunnel uses more than one underlay tunnel. So we have, as we said, the underlay tunnel is the physical networks, transport networks. So the overlay tunnels is logically created over these underlay tunnels. So there can be more than one underlay tunnel within an overlay tunnel. So the overlay tunnel uses multiple. So the overlay tunnel can be defined in case we can say the overlay tunnel consists of multiple underlay tunnels and transport depending on configurations. So configurations are given uh, for managing the underlay tunnels that are present within an overlay tunnel. So the SD-WAN uses an overlay tunnel to manage these and already existing WAN networks. So we can say the WAN networks as underlay tunnels. So in my slide, as you all can see, I have displayed the logical structure of an overlay tunnel. The overlay tunnel is a logical virtual tunnel that is created over the underlay tunnel. So here the underlay tunnels are MPLS, broadband, and 4G LTE that is present. So the overlay tunnel is the logical connection, logical and virtual tunnel that is created over these networks to efficiently manage the network flow through these networks. So next comes the dynamic path controlling feature of an SD-WAN. So the SD-WAN gives the user the ability for ability to choose the appropriate underlay tunnel on a per packet basis. So as we know, the data that is sent through any network is in the form of packets. The packets can be defined as a unit of data that is being transported through the network. So the SD-WAN makes the ability to the applicants to choose the appropriate underlay tunnel on the per packet basis for more faster networking to occur. Okay. So the dynamic path control is controlled on a per packet overlay basis by configuring the options called link bonding policies. So the link bonding policies may plays a major role in case of a dynamic path control feature of an SD-WAN. So the link bonding policies vary with the three line characters as I have mentioned below in this slide. They are forward error correction, then comes the quality, whereas the quality is defined with four characters that are loss, latency, and latency, jitter, and mean opinion score of the network. Then comes the load balance of the network. So these three features uh, plays a major role in link bonding policies. So next we move on to the latency. The latency plays an important role in specifying the quality of a network. So we can define latency is the time it takes for a data or a request to go from the source to the destination. The latency in a network is measured in milliseconds. The closer your latency is to zero, the better uh, the latency of the network is. So the in case the latency is near to zero, the better the latency is. So if the latency is near to zero, less time is required for a request to go from the source to destination. Or in case for an example, we can say the data takes more time to deliver in case we send a email. If we have a larger attachment to the email, it takes more time. So in that case, the latency is higher, so time is taken more. Okay, then is the jitter. Jitter refers to the disruption in data flow across your network and usually occurs because of things like network traffic jams, improper packet queuing, and setup errors that occur during the setuping of a network. So, this is for jitter. Jitter is also a character which specifies the quality of network. Next is uh, we have defined both latency and jitter, but some of you may have some confusion in that as these are quite similar. Uh, so, uh, so latency is a term used to outline the amount of time it takes for a packet to transfer to its destination. In contrast, jitter is the delay that varies over time when a signal wails or jitters. So next is the mean opinion score. Uh, so we can say the mean opinion score gives the numerical indication of the perceived quality of the media received after being transmitted and eventually compressed using codecs. Codecs is the coding technique in case we are transmitting any media through any network. Mean opinion score is the numerical indication of the quality of the media that is transferred to the network. So the next slide gives a table where mean opinion score varies from 1 to 5. This is a basic table, so it may vary from if we refer to sites, it may vary with one another. This table gives a basic idea. In case MOS is 1, the quality of the network is very bad, whereas in case of 2, it's poor. Where in here, in case MOS is 5, the quality is excellent. So this is for MOS. That is mean opinion score of a network. Next is the traffic handling feature. Here we discuss the forward error correction and packet order correction of a network. Okay. The forward error correction is the forward error correction feature of an SD-WAN uses parity packets to deconstruct the lost packets to avoid retransmission. For this, I will show one figure. Okay. Okay. The figure is given here. You can see the figure, right? Okay. Uh, the figure displays a sender A and a receiver and B. As we said, the message is sent in the form of packets. If we, in a case of SD-WAN, the two networks MPLS and LTE is present in case they are both present, and the data is transferred to the B part, that is the receiver part, through an MPLS. As correspondence, the parity bits of these packets that is sent through the MPLS is transferred via LTE network parallel to it. So, in case of any missing parity, when it is received in the receiver end, the parity bits of the packets regenerate these packets. So, there is no uh, missing of packets when it reaches the receiver end, as any loss of packets is occurred, the packet is regenerated by using the parity of the packets. So next we move on to the packet order correction. The packet order correction is is another feature of SD-WAN. That is, in case of any out of order of packets occurs if while the packets are received in the receiver end, uh, each packet of uh, each packet that is transferred through any network that is included in the overlay tunnel of an SD-WAN occurs if any disorder happens when it when this sequence of packets reaches the receiver end, there is a sequence number that is given to each of the packets that is transferred. So these packets, in case of any out of order, by using the sequence number that is given to each of the packets, we can easily reorder the packets, and there will be no mistake that will be created within the message. Then comes the dynamic path control. As I have said, the overlay tunnel that is provided by an SD-WAN manages the network that is the underlay tunnels that is already present. So in case there is a higher traffic present in one of the networks that is present in the overlay tunnel, the SD-WAN shift the information to the next more faster network that is present within the overlay tunnel. So I think the traffic handling features of an SD-WAN is clear. As we move on to the basic figure is given. So the figure. Hello. Okay. So the figure displays the both control plane and data plane. So each of the packets that we send during the information exchange contain both control plane and data plane. So the control planes are situated through the in the orchestrator that is present in a SD-WAN, whereas the data plane uses the gateways and reaches the destination, or we can say the cloud destination that is specified. So in this figure you can see the Vela cloud. So the Vela cloud is a vendor. So this Vela cloud edge is vendor specific. This may change as we refer to other vendor sites. These figures may change. Okay, so the management plane uses a priority REST protocol to secure LTE for secure transmission of the data. So the data plane uses VCMP, which is a pro priority overlay tunnel, optionally securing via IPsec. And IPsec is a VPN technology for secure transmission of data. So the the next figure displays the network flow in an SD-WAN. So this figure is when there is a low priority data is sent through an SD-WAN. In case a low priority data is sent, it goes directly to the internet and does not use the gateway. So in this figure, the low priority traffic is if in case we are using a using Facebook, it is considered as a low priority. So it goes directly to the internet and does not use any gateways. The policy decision on what traffic is considered as low priority can be controlled, and what interface with on what interface it agrees on, not encrypted, as public domain applications are used in this low priority traffic case. So next is network flow in case of a high priority SaaS application is used. The SaaS can explain as a software as a service. So they are provided for handling the softwares that are used in the branches, as we can see in the figure. So leverage DMPO is that is dynamic multipath optimization to protect against link impairment. So in case we are accessing the SaaS applications, a higher priority network is provided for management. uh, accessing these SaaS clouds or accessing the software that are present in a SaaS. So the next is the network flow in case of edge to end edge VPN. That is policy control feature. In case a VPN is a technology used for safer uh, information interchange uh, in case we are using an internet. Or auto assign redundant gateways are used in case we are using internet to get to a branch within a network. So automatic failover in case of VCG failing occurs in case of H2N VPN. So this is for in case of H2N Edge VPN is present in network flow in an SD-WAN. So the next is edge-to-edge VPN using hub sites. This figure shows the edge-to-edge VPN using hub sites. The policy control feature in orchestrator. The orchestrator specifies the network flow in these cases. Strict, strict specifications are given in this case of edge-to-edge using hub sites. So this is for the network flow in case of H2 VPN. Next is network flow in case of H2 data center. In case we are using the internet to access the data center in an SD-WAN. So the internet is less priority networks. So an IPsec technology is used to decode the data that is transferred to the internet and then it is given to the data center. So, in case of network flows in high priority SaaS application through CASP, so the CASP is a SaaS provider, that is software as a service provider. So it uses gateways to access the SaaS in these cases of high priority SaaS applications. So the gateways provided. So in case the branches are needed to access the SaaS applications, the request is sent to the gateways, then through the SaaS application that is provided for the branches. So next is high priority traffic protection by a partner gateway. So a partner gateway is provided in case of high priority access to the SaaS applications, and so the optical encryption is provided here for protecting the information that is passed. So this is elaborated in this figure. You can see the information is passed to the uh, IPsec, then the information is transferred to the SaaS application for higher protected, uh, high, highly protected SaaS accesses. So as we said previously, the management plane is provided in the Velo Cloud orchestrator. So Velo Cloud is the vendor of an SD-WAN. So the the management plane traffic is protected by a DMPO using local gates, full stack back option to go direct in the event of data place. In case of a failure, the orchestrator manages these failures. Next, the last slide is that disadvantages that are faced by an SD-WAN. So the system is not 100% percentage immune from slow performance in case we consider an SD-WAN. There is no 100% immune from slow performance. Then comes the next disadvantage, that is SD-WAN do not offers any on-site security functions. Next is SD-WAN or SD-WAN offerings are vendor specific. So there is no specific common standard for an SD-WAN. Next, uh, next is every vendor's implementation is prioritized. So the vendors' priorities are considered in case of an SD-WAN. Next is SD-WAN devices from different vendors will likely not work together to automate your WAN. So these are the disadvantages that are faced by a SD-WAN. So next we conclude this seminar. So for the conclusion, we can say that SD-WAN is a simpler, more reliable, and cost-efficient way to manage the networks. With the right SD-WAN solution, you can design, deploy, and transport services easily without implementing any CLI configuration, which would require the services of an expert. That is, we can easily imply the SD-WAN to an existing WAN network. So there is a small case when there is a requirement of CLI configurations to functions. The SD-WAN may become complex. So that is a disadvantage for an SD-WAN. So if you are using an MPLS network, implementing SD-WAN with it will cut your WAN cost. So cost efficiency is a major advantage of the SD-WAN network. So this is for the conclusion of this seminar. So this is it. So any questions or doubts that you have, you can now ask. So any questions?